really wanted to thank Andrew for answering all those questions that I asked of him, because I asked lots of questions, and he threatened to get even with me today. So I just want you to know I'm glad he's out. So let's get started. I got to tell you a little bit about my previous life, and we all have them, of course. I used to go to 10 to 15 plants a year. A lot of them happened to be Perlite plants. Some were expansion plants, some were ore plants. What happened?
The cable.
The cable. So, because this was kind of a last minute thing, I'm going to keep most of my discussions to expansion plants, but a lot of it does pertain to ore, because it's the same basic concepts. Most of the plants I've seen, they range. There's some really basic plants that don't even have a thermocouple in them. And I've seen some that have been really instrumented. I mean, I've been impressed. I have seen plants that had furnaces that were little in diameter and big in diameter. I've had some short ones, I've had some really long ones. I've seen furnaces that were like this. I've seen some furnaces that were like this, and I've seen some furnaces that's like this, and I've seen some furnaces like this. I've seen furnaces with 1 feed port, 2 feed ports, 4 feed ports, and no feed ports. So why am I telling you this? I'm telling you because people come to me and they say, is there a right way to do this? No, there's just lots and lots of different ways. But the thing is, each person, each expanding operator, figures out a way to tailor what he's got to satisfy the needs of a customer. And the bottom line is, the customer is the only guy whose opinion means anything, because he's giving us money. And he gets to vote with his money. So he's telling people that if you got a furnace like this, or this, or this, or this, if it's worth it to him and he pays you, it's good, it's fit for use. So there's no right answer. That's number one. There's different possibilities. But when I've been talking to these plants about helping them design plans as to how to improve, their improvements aren't just cost reduction or profit improvements, because that's why everybody's in business. Sometimes it's new products, sometimes it's other, but there's basic things that are in common regardless of the type of location you've been in. And every one of them are applicable in one way or another. So what I'm going to try to do is share a few of those with you, because you should be able to use parts of it. And it's a little basic thing. So I said the goal, I even got a pointer here. The goal is to improve your profits. That's what we all want to do, improve your profits, and we want to figure out how to do that. But to do it, you need to establish value to know where to put your efforts. So once you've established a value, you know how much you can spend on something, and you know how much to expect to get out of it. A lot of times I've heard people say, well, I'd like to make this better, but they don't know how much better or what they're going to spend or how much they're going to get out of it. So you need to develop a way. Since all expanders are different, I'm going to kind of give you an example of how I used to do it, because it might help you decide how you'd like to try. So I'm going to pick one that everybody has in common, and that's called unscheduled downtime. I don't care what furnace you got, I don't care what you're doing, unscheduled downtime always costs you. And I'm using it because I've run into operations where the downtime is a lot different than normal, which means if it's different than normal, you should be able to do something about it. 5%. If you got more than 5% unscheduled downtime, you got a real opportunity. So I'm going to kind of use this as my example of what's going on. After that, I'm going to take and show you what I do in terms of what I call develop WAGs, because WAGs help guide you as to where you want to put your efforts. Then what I'm going to do is show you what I used as developing action plans to achieve things. And then we'll talk a little bit about the process, the basic things. Because I noticed when I was asking Andrew some questions, going, why are you asking me that question? We don't do that. That means others might do it. Well, if you know others are doing it, then you might explore it to see if it has value to you and your customers. That's kind of what it is. I even have a little sketch of a process to show you where a lot of people take measurements. Oh, this is a great big thing. It's called a KOI, and it's really small so you can't see it and it looks complicated. But the real reason for it is to let you know that it's important to define what it is you're doing in your process. If you don't have a definition that people are following, you'll get bad information right to start with. So I tried to get all the locations, I had 12 of them. I tried to get all the locations to go by definitions, and then everybody followed it. And I used the unscheduled downtime thing as a kind of an example because I had one plant that had really great unscheduled downtime, but if you took the number of hours and you measured the amount they made, they weren't even close. It's because they kept redefining what unscheduled was. The plant just broke down. Well, we're going to plan that next shift is scheduled down. If you have a definition that everybody agrees on within your organization, you get much better information. So I always insist on developing KOIs or key indicating indicators where you have definitions. Then I developed WAGs. And WAGs, for everybody's information, is my terms for wild ass guess. And the reason I say it is I've had people come in and say, would you give me an estimate? And I need it in an hour. So do something real quick, you give them an estimate. These people think that's a budget number and it's really a good one. It's not. So I always develop a WAG because if I tell somebody, or you go to tell somebody, something's going to save me money and here's how much, I can show you how I figured it out. And it only takes a minute to develop a WAG. You put down, in this case, it's 4,000 hours. I'm going to save 5% unscheduled downtime because my make-believe guy had 10. How much did it save me? It saved me labor, saves me gas, saves me electricity, it saves me 20 grand a year. That means I kind of got a feel for how much money I'm willing to spend to save my 5%. And the WAG's important because most of us have to justify to somebody why we need to spend money to do something physical. It's hard to go talk to somebody who's at a distance. I need money because I want to reduce my downtime a little bit. They don't care. It's that simple. They don't understand. Money, they understand. Next thing I always did is once you agreed on a project, I'm going to pursue something, I said, okay, let's develop an action plan. An action plan for operators, and every one of you guys in here is an operator. You're not really big into paperwork. I'd venture to say there isn't anyone in here that wouldn't be willing to work 12 hours a day instead of working 1 hour a day to write something. That's just not the type of people that are in this room. So you've got to make an action plan really, really, really simple. You got to say, here's a one-liner of the item, here's what somebody told me, here's who was responsible, and that's when it was due. And every couple of weeks you can ask them, and if you don't have to write more than one line, you'll get good information, and what you'll find is you'll get things done on a project that's important to you. And what that means is next year, this issue probably won't exist because you've taken care of it. And you have to do that with an action plan, and everyone in the location has to be aware of it. And it doesn't matter if you're a big operation or a little operation, this works really, really well. I've used it many, many times. It works really well. but you gotta keep it really simple. And that's how you do improvements. And now, what we're gonna do is talk a little bit about the process, and I'm gonna keep Andrew away so he doesn't answer questions. We all got ore, and I'm gonna kind of go through each of the processing things. We all got ore. We got poured ore, construction ore, we got filterate ore. The fact of the matter is, it's volcanic lava that's aged. And as it ages, it gets to expand, or get to the point where it does expand. But the problem is you get multiple flows, so it's not consistent. And what does everybody in this room want? Consistency. I call it the same old stuff all the time. I want the same old stuff from an expansion standpoint. I want the same old stuff from the sizing standpoint. And most of the time, the ore guys can give you the same old stuff, but many times when it comes into your plant, what happens is we get segregation. We put it in a big silo, and perlite ore, particularly if you have a broad distribution, starts segregating. And when it segregates, it's going to cause you a problem in expansion, it's going to cause you a problem in your rates. It causes all kinds of issues. Screen analysis is one way to know. Looking at it is one way to know. But how do you deal with it? Yesterday, what did we do? We saw a live bottom bin on filterate plant, didn't we? Why is there a live bottom bin? It eliminated any segregation that might occur. That's a great idea because it eliminated variable. Yet, you walked outside at the portable unit and you had a regular feeder. Well, does it mean this wasn't needed? It just meant each way was sufficient for the customer. But you need to know, if you see segregation, you can use a live bottom bin. You can use anti-segregation pipes. You can use multiple outlets. You could put an air cannon into your system. The finer grades in particular, for big silos, the air cannons do a pretty good job. The little Solimar, yeah. I've never found those good for ore. You just got too much weight, you just don't do the job. You'd like to say that'd be really easy to do and it'd help me. I haven't found it. But most of these others do. In terms of feed rate, everybody wants to get more feed because the more feed you get, the more product you get. Well, only some people use VFDs to increase the feed rate. Some people just open the feed ports a little more. You really need, in my opinion, some way to have a VFD to increase the feed rate, and you do it gradually, and that'll give you more material. Just trying to open a port or open a little slot doesn't work really good. And I say it because there's all kinds in this room, and I've seen all kinds. If you know this, you get choices. That's what I've seen. Splitters. I told you there's 1 feed port, 2 feed ports, 4 feed ports. You know, if you don't get the ore split equally, you're going to get more feed on one side of the furnace than the other. If you go to change a furnace tube and you see it all warped on one side, you better believe you just had uneven feed. And a lot of times, I find that people have no mechanism whatsoever to check the feed rates on each of their ports to make sure. They never even think about it. They had a splitter. Or, with open furnaces in particular, a lot of times you get more drop out in one place than another. Those are really easy ways to tell. And the fact of the matter is, if you don't have good split, you're not going to get good expansion, you're not going to get good life of your tubes. That's just it. What do we do when we expand product? We want light, loose weight density, because we all sell by density, right? Nope. Because we sell by our cost. Sometimes if you make it too light, you get too much bag house. I don't know in here how much people get, but if your bag house starts getting a lot more than 15%, you got an issue. So that's why so many people watch the loose weight density. And you generally, I found if you test once an hour, you're in good shape. Once every 2 hours, you start going past 2 hours, unless you're just running the same old stuff all the time, you're gonna probably get a lot of variation. That's just my observation. If I run into cases where somebody thinks there's a problem with expansion, I have people run fractional densities where they run multiple screens. How much material's on each screen and what's the density of it? Did you get a good expansion all the way across the line? A lot of people don't even know that. So that's what I'm telling you. Number of you, like yesterday, ran filter aid. And filter aid, you saw what? Waste being removed. Waste being unexpanded material. How do you control the unexpanded material? Or why? Well, you can look at it and say, gee whiz, this is ore. I didn't get it expanded. That's an issue. If it's waste, I really wanted to throw it away. But how do I control it? I always tell people, take your little glass beaker and put some filter aid in it and swirl it around, look like it had at the bottom, and what you'll see is little black particles swirling around at the bottom. And if you want to measure it, which makes it really simple, you just put tape up. And you go, well, that's a little bit of unexpanded material that got into the product. Why is that a big deal for a filter man? Well, have you ever had a filter man call you and say the bottom of the tank is filled with black crap and it's yours? I have. I have. Have you had a guy call you and tell you, my pumps are getting worn out really bad? How do you adjust your system to remove waste? You do it by the swirl test. It's really simple, takes only a minute. It works like a charm and it tells you I can make adjustments. If you don't, it'll come back to haunt you. Simple and easy. If you are wanting to increase production, I've seen guys go out and really speed up the blowers. I'm gonna suck the sucker dry, okay? Well, that sounds good because you got a lot more suction, but there's a magic number. I call it 2,500 to 4,000 feet per minute velocity, which is about 750 to 1,200 meters per minute. If you get going down that pipe too fast, you're going to have a lot of fines coming out the other end. And you're not going to know why it happened. It's just kind of a, I call it not a secret of the industry, but it's kind of a proven element that you need to be aware of. Recognize when you start speeding up your blowers, that's going to happen to you if you exceed those numbers. If you're below them, you're in pretty good shape. Always trend stuff. I love trends. I showed you those other things. I love trends. With trends, you can always tell how much material of this grade am I making every hour. And it's amazing how many places I've been in. I've been in more than 60 expansion plants that don't trend things. It tells you a lot. Packaging. We saw a lot of stuff earlier today on packaging. I'm just going to quickly go over it because we had some comments on it. You know, whether you pack by volume or you pack by weight, you can put it in open mouth or not. You noticed on the system today that he sealed the bag. And one of the advantages to that particular system is packaging, everybody knows, as dusty as can be. If you have a bag sealing system like he has, the bag's too big. It's easy to put material in, it doesn't blow back, your dusting goes down, you sealed it, and it stops dusting and a lot of dirt all the way around the whole plant. And I can tell you that if you take your product and you put it into a customer's place and it looks really good, the customer thinks you got really good quality. If you got a package that looks like crap, he's going to think that that looks like crap and it's bad quality. The only thing that we sell in many respects is opinion, and that comes from the visualization. People don't get to to really measure our product. So I had valve sealing, I had the tuck sleeve, self-sealing, seal gluing. We saw some different semi-bulk filling today with the video. And I said, well, I'm used to settling semi-bulk by shaking the hell out of it. And then I found, you know, I like impacting it where it shakes, bounces. It's an impact and it deaerates real well. Some people don't do it at all. Yesterday, I saw one I hadn't seen before, and that's take a ton of material and put it on top of the bag afterwards and smash it, and it made it really nice and square. I learn something every time I go to a plant. I really do. Bulk density, we heard a number of things on that. Flatteners, I noticed at the plant yesterday, the guys were hand flattening stuff. And I went, wow. I find out they're going to put flatteners in. Every place, in my opinion, is better off having a flattener in because it makes your package look good. You can't command a premium price if your package doesn't look good. And what are we trying to do? Get more money. So, that's it. Maximize the bag height to maximize the load. I don't know about you, but I've looked in many containers, and when I do, I see a big void at the top. That means I'm shipping air. I never ship a full load. And having looked at that, I'm going to use my little drawings here. I normally have a loading dock and it ties into the back of the truck. And I got to drive up the loading dock to put the material in the truck. But I've got a pallet and it won't go all the way in, so I got to make my pallet a little lower so I can get it in the door. What I have found is if you take a dock leveler and have a nice long straight dock leveler, you can darn near fill up that container. And it's pretty cheap, it's pretty easy. And it's something that virtually every perliter needs to do. Because let's face it, freight's one of the killers in expanded perlite. So, here's my little sketch. It's in the book. It's one of the few things that's in the book. The only thing I really want to point out about it, other than there's lots of little measuring points you might want to consider making, is this one right here. And this is the bag house. The bag house should be no more than 15%, or you got a leak in this area here. You either got a vortex finder issue, or you got a leak in your seal valve and carrying stuff over. But 15%, if it's more than that, you really should look at it, because normally we throw this away. If you're putting it back in, you've got to have another issue, and that is, how do you consistently put fines back in to the material? Always, in my opinion, always clean the bag house based on timers. If every X number of minutes it shakes, you're going to have about the same amount of material fall off, and you bring it back in the system. Anytime you talk to a bag manufacturer, he's going to tell you, no, put it on a Delta P, those bags will last a lot longer. But what happens is the bags gather more and more material before they slough off, and when they do, you get a whole bunch of stuff coming at you. So if you're bringing it back into the product, you're going to have a lot of inconsistencies. So my recommendation over all the years is put it on a timer. Don't listen to those guys. Okay? This all goes back to the goal. The goal is, how do you make more profit? You got to make more profit by focusing on the critical few. You got to take and establish value for each item you want to work on and make a decision. And you've got to continue to do that. And seeing how I've been in lots and lots of plants, I can tell you no matter how new your plant is or how old the plant is, there's things that you probably can do that don't cost a lot of money. So give them a whirl. And I'm going to end it unless you've got some questions, and I'm not going to ask.
I got a couple of questions for you. Just
Yep.
just when you finished, then you said go over to don't go over to DP pulsing.
Yes.
A week ago, the three of the bag manufacturers here in Australia that I contacted, we had problems with the bags, and they said what you need to do is go away from the time pulsing, go over to the DP pulsing. I believe it was probably an issue with the bags rather than the pulsing. But anyway, one of the other things I was going to say is that back at our plant, one of the things that we've been looking at, and we've looked at, and it's taken us a number of years to build up this information, but what we do is measure controls, I mean, if you can't measure it, you can't control it. If you can't control it, you can't improve it. So what we've done is we've developed a system there, and it's effective for us, but it helps us to do some sort of predictive maintenance. Now, I don't want to sort of air all our problems amongst everybody, but you know, our breakdown maintenance, it might work at about 2%, but you know, if it starts to creep up, you can see over a period of time that it has creeped up, and then so that's the prediction that well, that's the forecast that you're using, because you're using that information that you've gathered to be able to tell when something needs to be changed. So, and it works quite effectively for us.
Yeah. Well, I always have a couple rules of thumb that I've developed over the time. And one is, when you're talking unscheduled downtime, the majority of it should be mechanical. It shouldn't be operational. If you're fusing the heck out of the furnace a lot, that means you need to look at the process to see what's probably causing it.
Yeah.
Because you shouldn't be getting fusions all the time, or you shouldn't have plug-ups all the time. You should have mechanical things more than operational. And
Yep.
just keeping a list of what's causing the downtime will tell you that. And I've been surprised over the years how many times a lot of the unscheduled downtime was due to operational issues, not mechanical. So, yeah.
To go back to your question about or comment about the delta P, if you every 10, 15, 20, 30 minutes or whatever pulse the bag house, regardless of what you do, that bag house material will be a lot more uniform. If you're feeding that bag house material back into your regular production, maybe one time you have a delta P buildup of 30 minutes, another time 15 minutes. So your end material will be a lot different depending on which point in that cycle you are.
Yeah, but one of the things that they said to us when we were looking at the bags, what happens is if you're working on time pulsing, which we had been working on, it's not very effective if you're down for some time and you've got the bag house pulsing away. Your production throughput is reasonably low, and it's pulsing away because you're getting an ingress of material through the bag, which is going to cause I think they call it a migration of material through the bag that was causing a problem. Time pulsing had been working well for us. We weren't having a problem. I believe it was probably an issue with the bags that was causing us the problem, but the three of them said go over to the differential pressure pulsing.
That's to make the bag last longer.
Yeah.
It has nothing to do with making the product consistent. And bear in mind, with baghouse socks in particular, if you start and put a whole new set of bags in, your DP is really low. A year later, your DP completely clean is going to be a lot higher. You'll get about a 40% of the flow after about a year because it gradually plugs off. So the timer just makes a lot more sense from an end product standpoint, not from a maintenance standpoint that they're trying to work on.
Right.
So, anyways, is it lunchtime yet?
No, not yet, 12:30.
12:30. You told me 12.
I told you to end at 12, we have more speakers. after
Okay.
7 more minutes, Chuck, keep going.
No, I don't get 10 more minutes.
All right. We'll finish
There's just,
up.
any questions I'd be glad to answer.
Well, one of the first slides you had up there, you said something about the hopper had some sort of a discharge system. It didn't have a discharge system at the bottom of it. the system that we got at our place, you said that one of them had there was two types of system.
Wide bottom bin on the filter aid plant. The other one, you just have a hopper with the feeder out the bottom.
Yeah,
And-
but-
And it's just pointing out there's different ways to do the same thing.
Oh, okay, because the metering mechanism is further up the line, not to the
Yeah.
bottom of the hopper.
Right.
Okay. I thought you were saying that we
No,
didn't
no,
have
no,
anything
no,
at
no,
all.
no.
Okay.
Now, even there, when I was looking, I've dealt with a number of those furnaces. What I find is when you have the dual augers,
Hmm.
one will wear more than the other.